so yesterday we did geometric sequence, which is right here. Remember we talked about a sub n equals a sub 1 times r to the n minus 1. Add your recording, you gotta be quiet. And arithmetic, which I talked about kind of, it's similar to slope. Everybody got it? And so remember it's similar to slope because basically you have a common difference plus the original term, which is like the yn or stuff, but it's in an a sub n format. Today we're going to be looking at recursive formulas. And so explicit formula, Addie, mommy's recording, you gotta be quiet, allows you to find any term a sub n of a sequence using a formula. So basically, we can find any sequence using a formula in terms of n. You know how we found the 100 term, all the different other terms that there exist? That's what this explicit formula is. For example, if we have a sub n equals 2n, we know that basically 2 times anything will help us find the next number. So if we want to find the fifth term, we just plug it in. 2 times 5 is 10. Got it? Recursive formula is a way that it allows us to find, if I do the politically correct way, the nth term of a sequence by performing operations to one or more of the preceding terms. So if you remember yesterday, we kind of talked about how we kind of went backwards with the n minus 1, how when you subtract 1, it takes you to the one before, so it's still the same concept. So here it says, since each term in the sequence above, we're talking about here, 2, 4, 6, 8, 10, 12, is 2 greater than the term that came before it, we add 2 to the fourth term to find the fifth term. So basically we know it's plus 2 plus 2 plus 2 plus 2, right? So 8 plus 2 is how we get to 10. You can then write a recursive formula. So there's a formula called recursive formula which will help us to do that, which you kind of already know how to do it, but it's just a different way of looking at it. So a sub 1, which in the past kind of was like a y and stuff, but we're not talking about that. The first term is 2, and so we know it's plus 2 plus 2 plus 2. So basically, you add 1 to the previous term, add 2 to the previous term, add 2 to the previous term, add 2 to the previous term. And so the equation says a sub n minus 1 plus 2. Everybody got that? Jay, can you get that in this moment? Step outside and visit. A recursive formula for the sequence above would be a sub n equals a sub n minus 1 plus 2. Everybody got it? So we getting ready to, as long as n is greater than or equal to 2. Everybody got it? Okay, so it says find the first 5 terms of the sequence. So we see our starting number, first term is 7. And a sub n equals a sub n minus 1 minus 12 if n is greater than or equal to 2. So what we do is basically plug 7 into this term. So we're trying to find a sub 2. Then we plug in 7 and we end up with 7 minus 12. So it's replacing that, and we end up with -5. So to find a sub 3, we take our previous term and subtract 12, and we end up with -17. To get a sub 4, take our previous term and subtract 12, and we get negative. Oh, that's 17. I was like, I did something wrong. Negative 29. And then a sub 5, we take the previous term of negative 29, and we subtract 12, and we get negative 41. So our terms, first 5 terms are 7, negative 5, negative 12, negative 9, negative 41. You have to learn the recursive to fully understand what we're doing, even though I know some of you are probably like, oh, we just subtract the 12, so I could just do minus 12, minus 12, minus 12 to get to the next one. We're still kind of plugging it in and going through the actual process. Okay, here says, find the first 5 terms for the equation a sub n equals 3 times a sub n minus 1. So when we plug that in, we end up with negative 4 as our first. So basically, to get the second one, we do negative 4. Sorry, I didn't do that. 3 times. And then we plug in the negative 4, we get negative 12. A sub 3 is going to be 3 times our previous term, negative 12, when we get negative 36. How do we know it's a previous term? Because basically taking that nth term and doing minus 1. So we're going to the previous term. If you don't understand, pause it and just go back. I redo it. So a sub 4 is going to be 3 times negative 36, and that answer is going to be negative 108. And then the last one, 3 times our previous term of negative 108, and that answer is going to be negative 324. Everybody got that? If you think you fully got it, pause and try to do number 2 on your own. If not, then keep watching and I'll go through number 2. So this one says a sub 1, our first term is 5, and it wants us to do 2 times the term. So a sub 2 is going to be 2 times 5, which is 10. A sub 3 is our previous term times 2. 10 times 2 is 20. A sub 4 is going to be our previous term times 2. Sorry. And that equals 40. A sub 5 is going to be our previous term times 2. And that equals 80. So your first 5 numbers should have been 5, 10, 20, 40, and 80. Okay, and look at number 3. If you want to pause and try it on you can. Here we're starting off with a sub 1 equaling 8. Ooh, turn on that light, Jay. And so basically you're taking that term, the a sub 1. When you find the next one. You know what? Maybe I should plug it in. Maybe I don't understand. So here when that has that a sub n minus 1, it's basically saying, okay, if I'm going to find my second term, if I plug in that 2 in there, I'm taking that previous term, 2 minus 1 is 1, so that previous term of 8, and then doing minus 6. And so we get 2. A sub 3 is taking that previous term and doing minus 6, and we get negative 4. A sub 4 is doing the previous term, minus 6, and getting negative 10. And a sub 5 is taking our previous term, minus 6, and getting negative 16. And so, bless me. Our first 5 numbers are 8 to negative 4, negative 10, and negative 16. Everybody got it? And the last one, our first term is a sub 1 equals 32. And we see to find the sequence, we're taking a sub n minus 1 and adding 13. So basically, we take our previous term of negative 32. We add 13, and that one is going to be negative 19. Take our previous term, add 13, we get negative 6. And what am I doing wrong? I'm not writing my a sub 2, a sub 3, a sub 4. Our previous term, added 13, and we're getting 7. And the final one, 7 plus 13, and we get 20. Everybody got it? So it's pretty simple. You just take your first term, plug it into the equation, and solve. Then you do the previous term, plug it into the equation, and solve. And remember, it has to be n is greater than or equal to 2, because it can't be 1, because you do 1 minus 1 and it's a sub 0. But it has to be greater than 2, so that when you plug it in, you start with the second one. Questions on that? If you don't understand, just start over. Try to fully understand it. Read through it, listen to it again, and then hopefully you'll be able to catch on. So, in those problems, they gave us the equation and we just plugged it in to solve. Now we're going to learn, how do I write the equation to solve? Writing the recursive formula. So if we look, it says complete the following steps to write a recursive formula for arithmetic or geometric sequence. First, you have to determine if it's arithmetic or geometric. We learned that yesterday. Remember, arithmetic is going to be plus 1 plus 1 plus 1 minus 1 minus 1 minus 1. Common difference. And then geometric will be times 2 times 3 times 2 times 2 times 2, or times 3 times 3 times 3, multiplication. Once you figure out if it's arithmetic or geometric, then you use the following formulas. Everybody got it? The first one, arithmetic, means a sub n minus 1, so that second term plus the common difference. To us, we know d basically is the slope, kind of, sort of, but not really. And geometric, of course, we did many problems yesterday where we take our common ratio times the a sub n minus 1, where r is the common ratio. And then we state the first term and the domain for n. So let's look at some sample problems, and then basically you kind of get it. So here it says, write a recursive formula for 2, 16, 36, 6, and 1, right? Remember, if you can't figure out what they're multiplying to go this way, then remember we go backwards, right? So if we do 36 over 216, that actually reduces to 1 over 6, because both of those are divisible by 36. We do it here, we realize we're multiplying by 1 over 6, so that means it is a geometric sequence, and so r equals 1/6. That's our common ratio. Yesterday's homework, got it? So since our geometric ratio is 1/6, step 2 says, what's the formula? So we know our formula is a sub n equals r times a sub n minus 1, right? And so basically, if we were to plug our r in, we would get 1 over 6 times a sub n minus 1, right? And then step 3 says, what is the first term? So we plug in so we know our first term in this problem was 216, right? So our a sub 1 equals 216. Everybody follow me? And then from there, you would go through and solve the problem. So those are our steps to solve. Everybody got that? And so then our equation basically is what we wrote right there. Everybody got it? Because we're just writing the equation. So let's look at practice sum. So example 2 says, write a recursive formula for each sequence. First, we need to see what kind of formula it is. And if we go from 22 to 16, hopefully you see you're subtracting 6, minus 6, and minus 6. So our common difference is minus 6, right? So we'll say d equals negative 6 for our common difference. And our a sub 1 in this problem, because it also said to identify a sub 1, is 22. So when we write the recursive formula for this, we have a sub n equals a sub n minus 1 minus 6. For n has to be greater than or equal to 2 in order for it to work. And there's the formula. Everybody got it? Number 2. So from here it's plus 5, plus 5, plus 5, right? So that means we have a common difference of a positive 5, right? So when we write our equation, we start off with our a sub 1. We know that's negative 8 because you need to know a sub 1 in order to do the rest. And the rest of the equation is a sub n equals a sub n minus 1. And then what was our common difference? Plus 5. And n has to be greater than or equal to 2. Want to pause it and try 3 and 4 on your own? You can. If you still don't get it, let's look at it. So here, we see we can't do plus 10 plus 10 plus 10 doesn't work, so this one is my times 3 times 3 times 3. So then what kind of sequence this is? Is this, you should have said geometric. Since it's geometric, we know our R is equal to 3. So we have a common ratio, right? And so if we write the equation, the recursive formula equation, a sub 1 equals 5. That's our starting one, right? And so then the equation says a sub n equals 3, our common ratio, times a sub n minus 1. And then n has to be greater than or equal to 2. And there's our equation. Everybody got that? Let me erase it just so I can write. Then the last one, how are we getting from here to here? If you can't figure it out, go backwards. 81 over 243. It reduces to 1/3. So our common ratio is multiplied by 1/3, right? Now that we know our common ratio and that this is geometric, we start off with our equation. We have to know the first term. And then we know that a sub n is equal to the common ratio of 1/3 times a sub n minus 1. And n has to be greater than or equal to 2. And we need all of that information because with writing this equation, somebody who just walks up and sees the equation, they have to have enough information to solve it. To know I start with my first term. Plug it in, multiply times the common ratio, and it has to be greater than or equal to 2. And that is how you write a recursive formula. And lastly, we're going to look at how to go backwards. This makes it all kind of come together. So here we're going to move back and forth between recursive and explicit formulas. So here it wants us to write a recursive formula, but it's given us, what is it giving us? It's giving us the explicit formula for an arithmetic sequence. How do I know it's arithmetic? Because when I look at the format, it kind of, quote, looks like y equals mrs b, so I know it's arithmetic. Except it's not y equals mrs b, it's an arithmetic sequence. And our slope is like 6, but how do we say that in terms of explicit formula? That is our common difference. That means they have plus 6 plus 6 plus 6. And then if I plug in a 1, 6 times 1 is 6 plus 3. That means the first term, or the a sub 1, was 8, right? So 6 times 1, you know how we used to make the charts with slopes and plug in 1, 2, 3, 4, 5. So we plug in a 1, 6 times 1 plus 3. And then that tells us that the first term is 8. So now that we have taken this explicit formula for arithmetic sequence, and we're taking it to a recursive formula, we have the information we need. So when we write the recursive, remember step 1 is to identify the first term, and then step 2 is to write the equation. So we have a sub n equals a sub n minus 1, and our common difference was 6, so we have plus 6. And then remember, n has to be greater than or equal to 2 in order for it to all make sense. So that's how we went from explicit for arithmetic to a recursive. Here, it wants us to write the explicit formula for this sequence. What kind of sequence is it? If we look at it, we're doing 0.8 times a sub n minus 1. That's a geometric sequence. So we have a geometric sequence, and so now we're getting ready to go backwards. It's written in recursive form. Go backwards and write the explicit for this. So what do we need to identify? Well, we already have one thing right there. A sub 1 equals 120. And then we also have the common ratio, which is 0.8, or we could say 4/5, right? And so this is what we used to do what we did yesterday. So we're going to write the explicit or just the geometric sequence. And so with the geometric sequence, we identify that a sub 1 equals 120. And when we write our equation, we have a sub n. And remember the formula was the r, which is 0.8, times, my mind just went blank. Oh my, don't go blank. Back it up, back it up. I forgot something, and I'm sure some of y'all are correcting me already. When writing a geometric sequence, we have our first term times the r raised to the n minus 1 power. And that's what you did for homework. So we're going from this recursive geometric to an explicit geometric. So our first term, and we take our first term, multiply it times the r ratio raised to the n minus 1. And this was pretty much your homework. Y'all dealt with formulas like this. So this kind of sums it all up from looking at recursive, explicits for arithmetic, explicit formula, and geometric sequences, and bringing it all up. So all this is just basically taking the common differences, common ratios, and writing a formula for it. That works for everything. Any questions? It is a difficult unit, not too much. Once you get the hang of it, it just goes fast. It's just learning the formulas. So if I were you, I would start all the way over, and watch it again to fully understand.